Good morning. This is Mr. Spencer, and today we're going to be discussing simulations. In our previous meeting, we talked about how we needed samples that modeled the population, that our sample needed to look like the population, and the population being a large group. One of the ways we model things is using simulations. So we're going to run a simulation, and I'm going to say right off the bat that this is something new that you probably haven't done. Initially, because it's a long multi-step process, it seems challenging. It's actually comprised of a bunch of really easy steps. Not to scare you, but I want to show you all the steps are necessary. So the recipe for success here on page 7 shows all the steps that we have to go through to run a successful simulation. That said, you'll be able to use the recipe card with you on your quizzes and tests, but it's very important that you pay attention so that you know how to utilize it. But it's a great step-by-step process. So we have some vocabularies. Well, the reason the simulation is successful is it shows you what could happen. So think about this. If I ask you how many heads you might get when you flip a coin 8 times, you probably say 4. And that's true, you would expect it to get 4. But it's possible you would have gotten 5, it's possible you would have gotten 3 or some other number. And basically a simulation lets you model that, okay? It lets you model the likelihood of that happening because it employs randomness. Now we are going to use random number tables. And these numbers are completely random, and the way they came up with those numbers is they rolled dice. They had a 10-sided die, they rolled it, and they'd roll it, and every time they roll it, they'd record the number. And that's much more random than a computer or a calculator because those numbers run through an algorithm. All right. A component is the most basic thing. So we talked about flipping a coin. So the component would be flipping the coin. The outcome would be whether it was heads or tails. But in this particular case, I said, hey, a trial would be how many times did I have to flip it until I got 4 heads or 5 heads, and a trial would happen after I completed that number of successes. All right. So I already said how many heads would I get if I flipped a coin 8 times? And basically 50% times 8 equals 4. And the answer, are you certain about that? Well, you just said that might happen, but it won't happen every time. It's not likely to because of uncertainty. So this is why we run a simulation. So there are multiple ways to run simulations. Right now, we're going to start off with 2-digit numbers, and we're going to practice assigning the numbers of chance and failure. So off to the side, I made a list of possibilities. I could get 0, 0, 0, 1, 0, 2, 0, 3, all the way to 99. I can't get 100 because 100 is a 3-digit number, okay? I can't get 100 because 100 is a 3-digit number, so I can only use 2-digit numbers. So we can either use 0, 0 for 0 or we can use it for 100. 0, 1 I'm going to use for 1, 0, 2 for 2, and you can assign it any way you want to. So I will assign 2-digit numbers such that 0, 0 and 0, 1 through 49 equals heads. Now I did that because I need it to be heads 50% of the time. And so basically I need 50 numbers that are heads. So that'd be 1 through 49 or 0, 1 through 49. Well, that gives me 49. Then if I put 0, 0 on it, I now have 50. That means the rest of the numbers, which is going to be 50 through 99, will be tails. All right? And so we're going to flip the coin until we have 4 heads, and then we'll repeat the simulation 3 times. All right? And I'm going to switch screens. So I'm going to pause this for a moment and switch screens to show you how that works. And well, actually, I'm going to show you what it kind of looks like. This is what it kind of looks like. But let me show you how I got that, because that's probably a bit confusing and scary. So please pay attention. And I'm going to pause this recording. All right, I'm in the advanced mode, which scares me because I'm likely to make a mistake. But we said that 0, 0 through 49 equals a head. 0 through 49 equals a heads, and everything else is tails. And I want the number of heads. Well, so I look at that very first two-digit number, and it's a 52. Well, 52 is not a heads, so I scratch it out. That didn't help me. That's a tails. Then I have an 82. That didn't work, okay, because that's also a tails. But then I have a 24. And notice I bridged the gap, and that 24 happens to be a heads. So I now have one heads. Then I have an 89. That's not a head. Then I have a 90, not a head. But fortunately, I have an 03, and that is a heads. So now I have two heads. But I need to get 4, 64, 83. Hey, 48. That's a heads. Well, I switched colors. Oh, well. Didn't mean to do that. Then we have a 61, a 54, a 68, and now we also have a 06. And at this point, I can count them, and I have 1, 2, 3, 4 heads, and that's the end of my trial. Well, how many times did I have? How many coins did I have to flip? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for trial number 1, I had to flip it 13 times in order to get 4 heads. All right, so that's our first trial. So let's try this again. Let's see if I can not switch colors as much. Well, the first number happens to be a 31, so that's a heads. Then we have a 64, which is not a heads, a 54, not a heads, a 55, not a head, a 52, which is not a head. Then we have a 78, which is not a head. But then we get to a 25, and that's a head. A 56 is not a head. A 47 is a head. A 94, not a heads. And then we get to a 21, and that is a head. So count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So on trial number 2, I had to flip it 11 times. It does not look like an 11. I had to flip it 11 times to get the 4 heads. All right, we'll run this one more time. So, because we're repeating the simulation 3 times. 38, that's a head. 80, not a head. Then we have a 44, that's a head. 56 is not a head, 87 is not a head, 85 is not a head, but then 32 is a head. And then I have 05, which is also a head. So in this case, so that ended my trial, and I had to, how many components? 1, 2, 3, 4, 5, 6, 7, 8. So in this case, I had to flip it, on trial number 3, I had to flip it 8 times. So in total, 13 plus 8 is 24. Add 8 more to it is 32. I divide by 3, and this took me almost 11. I had to flip it almost 11 times to get, and this should be 10.666. So based on my simulation, I would expect to flip it 10.66 times. I'm going to pause this for just a second.